Okay, this is the practice final on the fundamentals of calculus from this year. I'm going to run through first the notes and then do the problems. And remember, really, you want to complete this plus the delta review, for each unit. Okay, that's 1 through 6. All right, starting with limits. So for limits, there's the notation. So we have limit as x approaches some a of f of x. Okay, this is the general notation. This means from both sides. Then you also have limit f of x as x approaches a with a little line there, with a little like sort of negative sign, and that means from left. And then we have limit f of x, x approaches a plus. That means from right. And we'll go over this in the first problem. I'll go over like how those are used. And then we'll have just regular f of x, which is value of function. Okay. Tangent, secant. You just have to know what these mean. So tangent line tan is touch. So tangent lines are lines that touch the function one time. This right here is a tangent. Okay, because it touches it this one time here. The secant will touch it twice, like this. There'll be 2 points connecting. This is a secant line. This is a tangent. Okay. Power rule. Now we're into derivatives. Um, derivatives. So power rule is you got to know this. Derivative x to the n equals n x to the n minus 1. We'll be doing some of those later. Product rule. If h of x equals f of x, g of x, then the derivative equals lefty right plus righty left, which is f of x, g prime of x plus g of x, f prime of x. Okay, quotient rule. Similar but division. H of x equals f of x over g of x. It's low d high minus high d low. So low g of x, d high f prime of x, minus high f of x, d low g prime of x, all over g of x squared. Again, no card. No card. Put it in. Chain rule. If h of x equals f of g of x, then derivative is f prime g of x, g prime of x. Okay, implicit differentiation. We'll get to a problem that does this, but basically, well, I'll walk through the steps later. The implicit differentiation is better solved with a problem with an example. Integrals, reverse power rule. Okay, the antiderivative of x to the n, when you take the integral, is x to the n plus 1 over n plus 1. Have to know that rule. Most, like, there's reverse power rule and the power rule, those are essential. So have that down. Oh, it's b plus c. And the fundamental theorem of calculus. This is if you take the integral of some function from a to b, you take the antiderivative of it and set it from a to b, and then it's f of a minus f of b. We'll do some. So, I mean, it's not that much, but all this on the note card. It's really, when I look at it, it's, yeah, this is a fair bit. It's going to take you a bit to review this and practice this, but on the whole, this is fair, and you can learn this and perform on this on the test. Okay, first we have limits. So let's start with the value of the function. This just means the value of the function on the left here. So f of 4. What is the value of the function at 4? The value of the function at 4 is 0. That equals 0. The value of the function at negative 1, remember, we're looking for where it's filled. So notice at negative 1 how it's not filled in any of these. That means it's undefined. I'll also accept D and E. Like, I'm not going to take points off for that, but that's undefined. f of 0, go to 0, go up. It hits 1. So remember, it's where it's solid at that point, the y value where it's solid. F of negative 5 is 2. So because when I go to negative 5, I go up, it's at 2, solid at 2. Now we go to limits. Limits are what the function approaches. So at 4, the function approaches, it doesn't approach 0. It approaches 1 here. Notice that the function is going towards 1. Negative 1 from the left. So here's negative 1 right here. And I'm going to follow the curve from the left approaching it. I approach 3. Limit as x approaches 1. I go over to 1. It's just the value here from both left and right. It's about, I'll take like 1.8, 1.75, 1.9. And then negative 2 from the left. So I go negative 2 from the left up here. It is 2. Okay? And this is unit 1 delta. Unit 1. Right? Next, we are ordering. So this is where the knowledge of the tangent and secant lines are coming. You have a bunch of tangent and secant lines, and you have to arrange them. So f of b is this value right here. This is a. Okay. CAD is this one here. That's going to be my b. Derivative at d is right here. It's going to be my d. CF right here. That's going to be my c. And the derivative at c, it's a 0 line. That is my e. Sorry, guys. Yeah, CF. Okay, good. Sorry, CF is a D, and derivative at D is C. Sorry, that's confusing. Okay, I realize like this is a little confusing here. It might make sense to just do it one at a time. I will go through them one at a time. So which is the least slope here? Well, least slope means, in other words, like most negative, right? Most negative. There's only one slope here that's going down, and that's C. C is the only one going down at f of d. So that's going to be that's C. And then, so I'm going from the most, visualize this pencil as a slope. I'm going from the most negative to most positive, the most down to the most up. So that's most down is C. Then as I move my pencil or my pen further up, E is the next least steep. E would be a slope of 0. And then from there, D, and then B, and then A. Okay? In terms of steepness. A is the most steep. Look how steep A is. B is a little less steep. D is a little less steep. Then E, then C. So they go from C to A. Find the derivative algebraically. You can leave your answers as negative exponents. Okay, so this is using the power rule. Okay, 3 times 4, 12. X, 3 minus 1, 2. Plus 2 times, there's nothing there. 2 times 1 is 2x. And then negative 4 times 2 is minus 8. Minus 1 is negative 5. That's it. Don't forget the x. Right? Some other ones that'll come up, the derivative of like 8x is 8. And the derivative of some number, let's call it like 5, is 0. Okay? Moving on. Product rule. So I'll have my notes on next to me. But this is product rule right here. We're multiplying two functions together. This is your f, this is your g. So f of x equals 7x plus 2. Derivative of f of x equals 7. G of x equals 3x squared plus 8x minus 4. Derivative of g of x equals 6x plus 8. Okay, let's do it. So lefty right plus righty left. Left is 7x plus 2. D right is 6x plus 8 plus right is g of x. That's 3x squared plus 8x minus 4 times 7. That's my d left. All right, so again, this is my left, d right, right, d left. Okay? That's fine. Given the function, again, it's similar, but it's quotient instead of product. So different formula. Remember, it's it's you wrote it down in your notes. It's g of x, f prime of x, f of x, g prime of x, g of x squared. So again, I'm doing the same thing where I'm going to label them. The numerator is f of x. That's going to be 1 plus x squared. The denominator is, sorry, not the denominator. The derivative of that is just 2x. The denominator is g of x. That's 2 plus x. And the derivative of that is just going to be 1. Because the derivative of 2 is 0. Derivative of x is 1. Now plug it in. Low d high minus high d low. So low is the denominator. So again, you can use your notes, but it's going to be 2 plus x, d high, 2x, minus high, 1 plus x squared, d low, just 1. All over, low squared. That's 2 plus x squared. Okay? So identify f of x, g of x, find the derivatives, then plug them in to the formula which you have here. Okay? Chain rule. So again, derivative of the outside, keep the inside the same, times the derivative of the inside. Okay, so we're going to have 5. Derivative of that power of 5, we bring out front, negative 7x squared plus 8, all that to the fourth, times the derivative of the inside. That is negative 14x. That's it. Done. Derivative of the outside, keep the inside the same, times the derivative of the inside. Okay, derivative of exponentials. Oh, I forgot to add this in my notes. I'll put that right here. But derivative of e to the x equals e to the x. That's the one you need to know. Okay, e to the x is e to the x. So here, this is a chain rule situation. We have the derivative of e to the negative 3x to the fourth. Okay, chain rule. Take the derivative of the outside. The outside function is e to the x. So it's e to the x, so it stays the same. E to the negative 3x to the fourth times the derivative of the inside. That's the inside. So we're going to do times negative 12x to the third. That's it. Okay. Implicit differentiation. So for implicit, I left this off the notes because it's easier to actually explain doing the problem. But you take the derivative of everything across as normal. We're going to have 2x plus 3y squared y prime. This is the main difference. Whenever you differentiate a y, you're going to multiply it by a y prime. 4 is 0. Derivative of 4 is 0, so I leave it. Minus 6x squared equals 1. Then step 2, get this y prime by itself. Okay, so I'm going to move this over, minus 2x, and I move this over, plus 6x squared, plus 6x squared. So now I have 3y squared y prime equals 1 minus 2x plus 6x squared. So I moved everything over, so I have the y prime term alone, but I want just the y prime, so I'm going to divide it by 3y squared to cancel those. And this gets all divided by 3y squared, and that's your answer. So you differentiate it across, get the y prime by itself, divide by the other term, and that's your answer. Okay, integrals. Good. Okay, this is just, all you need to know for these is the reverse power rule. So first step is to take the antiderivative. This is right here, fundamental theorem of calculus, part 2. Integral of x to the third, you add 1, divide by that number. So we're going to get 4x to the fourth over 4 minus 3x squared over 2 minus 5x, all from negative 1 to 2. I'm going to simplify this a little bit. Those 4's are going to cancel. Then I'm going to plug in a 2 into this. I'm going to get 2 to the 8th minus 2 squared over 2 minus 5 times 2. All of that minus, sorry, I don't know where this 2 to the 8th came from. That's 2 to the 4th. Sorry about that. 2 to the 4th minus 2 squared over 2 minus 5 times 2. Good. Minus negative 1 to the 4th minus negative 1 squared over 2 minus 5 times negative 1. Okay. So now we're just going to do the math. 2 to the 4th, 2 times 2 times 2 times, use a calculator, but 2 times 2 is 4, times 2 is 8, so 16. 2 squared is 4, 4 times 3 is 12, 12 over 2 is 6, so 16 minus 6 minus 10. So that's 0. then minus negative 1 to the fourth is just 1. Negative 1 squared is 1 times 3 is 3, minus 3 over 2. And then 5 times negative 1 is negative 5, so it's going to be plus 5. So I have 6 minus 3 halves equals 4.5. Okay. Again, calculator gets you through all this. This is just calculator. Calculator. All right, here, integral of 5. Integral root of 5 is just 5x from 4 to 12. Plug in 12, we get 60 minus 20 equals 40. Okay. Plug in the 12 in, you get 60. Plug in the 4 in, you get 20. 60 minus 20 equals 40. Integral of 5 is 5x. Last one. Integrate 3x squared over 2 plus 10x, all from 3 to 5. Okay, plug in the 5. That's 25 times 3 is 75. So 75 over 2 plus 50 minus 9 times 3 is 27. 27 over 2 plus 30. Okay, so it's a bit of a messy one. Let's see if I can combine. So that's going to be 50 minus 30 is 20. 75 minus 27 is that's 55, 48. So I have this and 48 over 2. 48 divided by 2 is 24. 24 plus 20 is 44. Okay. Again, take your time, use a calculator. 75 divided by 2 plus 50. 27 over 2 plus 30. That minus that is 44. Okay. Last one. We're nearly done. This is the area between curves. So you have a shaded region between two curves, and you need to find the area without using calculator. And this is the last thing on the test, last unit. So to do this, it's just the integral of the top minus the bottom. Okay, so the top function here is this negative 4x squared plus 4x. So we're going to do integral from, if you look at where we start integrating, it's right here at negative 1. And we're going to go until 2 of negative 4x squared plus 4x minus negative 8 dx. Okay. So it's the integral of that top function. That's the top right here, and that's the bottom. So it's a top function minus the bottom. The top, which is negative 4x squared plus 4x, which I gave to you, and the bottom. Okay, now we're going to simplify this a little bit. We're going to get negative 4x squared plus 4x plus 8, because minus the negative is plus, dx, integral negative 1 and 2. Now we take the antiderivative. We're going to get negative 4x to the third over 3 plus 4x squared over 2, which is just 2x squared plus 8x from negative 1 to 2. And then we're going to do, we got some extra paper here. We're going to do f of 2 minus f of negative 1. So plug in the 2, you get 2 to the third is 8 times negative 4, negative 32. We get negative 32 over 3. That's 4 times 2 is 8 plus 16 minus, plug a negative 1 in, that's negative 1 times negative 4 is 4 over 3. Negative 2 is 1, 2 plus 2 minus 8. So we got this minus this. You're just plugging in the values. Let's see if we can simplify this. So 8 plus 16 is 24. 2 minus 8 is negative 6. 4 thirds minus 6. Negative 32 over 3 plus 24. All this minus this. 24 minus negative 6 is 30. 32. Negative 32 minus 4 is negative 36. That's negative 12 plus 30 is 18. I think even the hardest part about this is just plugging it into the integral. And for that, just use a calculator. Don't stress too much, just use a calculator. And that is the practice test.